So welcome to this clip, to this short video clip on inverses. So inverses of a matrix. Another matrix B is an inverse of A. If you multiply that A by B, you get the identity matrix. And if you multiply B by A, you change the order, you still get the identity matrix. So we want to look at a method for getting the inverse of a matrix using row operations. The method that we are going to use is called Gaussian elimination. So what you do is, in that method, what you do is this. You form an augmented matrix with the right-hand side being the identity matrix of the same order. Then you perform row operations so that the matrix A, which is on the left-hand side that you want to obtain, becomes an identity. And then you get a new matrix on the right-hand side. That matrix that you get on the right-hand side is the inverse of the matrix. So let us just get a look at this. So we want to find the inverse of a matrix A using Gauss-Jordan elimination. So this matrix is a fairly simple matrix with the small numbers, just numbers, not more than one. Numbers, we just use it's order 4, so we just use the 4 numbers from 0 to 3. So there we are. This is how we are going to do. We set up this augmented matrix and apply row operations to reduce it to this form. So what we are going to get here, you get an inverse there. So this is the first row operation. So the first set of row operations, the augmented matrix, it is double the number of columns because you have the identity on the left. So the column, you are going to eliminate, you are going to introduce zeros here. So you are going to have a 0 there and a 0 there. This one is already a 0. It's just a plus for us. So let's look at the row operations that we did. 2 of them. We are just going to do it for column 1 and column 2. We are going to do the eliminations. So first of all, we eliminate row 1. We are going to make row 2 equals to row 2 plus row 1. Then we make row 4 equals to row 4 minus 3 row 1. So we are going to introduce zeros there. We are going to perform these row operations for the entire set of these operations there. Or if you perform these row operations for the rest of these things, you obtain precisely this. So what would have changed here is this first row and then the first column. The rest of these 3 are going to be the same. For the second row operation, we are going to swap row 2 and row 3. We are going to swap row 2 and row 3. And then use that to eliminate row 3. So we just do these 2 row operations there. This one and that one. So we are going to have here, we are going to have here, after performing the row operations, from this, after now doing this row operations, we would have eliminated the zeros here. We are going to keep this as it is. Then here everything now has changed except for the last column. So the idea is to end up with ones on the diagonal and everything above there to be all zeros. That's what we aim to do. So next we are going to eliminate this 21 over 2. And we have something remaining where we have 3 here. So that's this elimination now will give you an upper triangular form. So you have the matrix and then everything below the diagonal to be less than 0. So how do we eliminate this? we make row 3 1/3 so that it is a 1, and then we use it to eliminate the other ones, to eliminate x3 from row 3. So we're going to perform these row operations, that one and then this one. So if we perform these row operations, we have a 0 here and 1, and then it's 15. Now we should focus on now eliminating these ones. So because we are going to use it to have a 1 here, we can use it to eliminate this one at this position, at the position 3, 4, and then this one, so that we have zeros. We're now going to come back from here, going back up there, introducing zeros. So back, we are doing that back elimination process. So we're going to eliminate in column 4. These are the row operations that we are going to do. And if we these are the row operations, row 3 minus row 4 will give us our new row 3. Row 1 minus row 4 gives us our new row 1. So we're going to eliminate the entries there. We're going to go backwards. So our new matrix on the right hand side is this. If you look at that, then we have now a 1 here. We can use this one to eliminate elements in the third column so that only the 3 entry remains. So we can add row 2 to row 3 to eliminate this one. Then you can subtract 2 times row 3 from row 1. So these are the 2 row operations. So if we do that, we are going to have zeros there and zeros there, and you have this matrix. So now the next thing is just you are going to normalize this. Make this one a 1. And if it's a 1, you are going to use it to eliminate these other 2. So we just look at that row operations. We are going to eliminate in column 2. So we're going to use these 2 row operations. Row 1 becomes this, and row 2 becomes that. And after doing this row operation, you now have this on the left hand side. You have the identity matrix here. Then on the left hand side, you have the identity matrix. And then on the right hand side, you now have this matrix. This matrix is the inverse of the matrix that we started with. So it is the inverse of the matrix that we started with. So to get this inverse, it's just a matter of getting the things on the right hand side, and then your inverse is equals to this. So that is the way how you find inverse using the Gauss-Jordan method. This is how we find the inverse of a matrix using the Gauss-Jordan elimination.